in dual filtration, it will be converted into single filtration. At that time what happens? In 1 minute, you just need to turn up 2 valves. This is open 1 valve. Process is continued. So at that time you can remove it. You can replace with the new one. And after that you can fix it. Okay, to remove this filtration system, it will take more than 30 minutes. If you are stopping for 30 minutes, starting change, then it won't match. So to avoid stoppage of production, what we did is the dual filtration system. Okay. So how to check whether it is clogged or not? So from outside it looks like a black cylinder. Okay, to check that, as I told you, initial pressure sensor. So here you can see it. Here I have the initial pressure sensor. What it will do? It will take reading in inlet, inlet output. So that difference will be calculated and it will be highlighted in the monitor as a clock. If it is more than 80 or 90%, then you need to replace it with the new one. Okay. Okay, and one more thing you asked, right? So here what we are doing here, the circulation of the gas. So at what speed gas is circulating in the system, it will be highlighted. It is a flow meter. So it will show you the velocity. After that I told you this is lower in it to maintain the circulation. Okay, after that here at the top you can see that this is scanning in ये ज्यादा नहीं होगा. तो जैसे हम वहाँ पे देते हैं ना जो जबरदस्ती, अगर वो हेवी मटेरियल है, then we will keep 20% is the initial speed. In that we can go up to 49 only. After 49%, we can't get more speed. Okay, it will be limited up to 49. So you can rotate up to 49%. But in case of essence, if you are keeping more than 30 this threshold top, then solid particles will fly. So if you get clogged only, then only you need to speed. Otherwise you need to maintain max to max flight. In case of aluminum, we are starting it from 12 or 30. So if you are keeping more than 20 in initial state, solid particles will fly. So depending upon density of the material, we need to maintain the speed of the part. Lower. Okay, after that here we are having scanning unit. Okay, so in scanning unit we have 3 major parts. So first one will be the collimator. After that we have beam expander. Okay, after that we have scanner. Okay, so here what is the function of these 3 units? Okay, so here initially we are having laser unit. It's that side. Okay, in that side I will show you later. From that side through fiber, laser will be traveling here. Okay, laser has to be generated like this. So these are the different paths like this. So at that time what happens? Laser will become transparent. What we need focus diameter, which is having very fine capacity. So it is having energy drop will be there. To make it laminate, we have a unit called as a collimator. What it will do? Whatever turbulence is there in laser beam, it will make it as a laminate. Once it becomes laminate, so here what happens? In front there will be multiple fiber. From multiple fiber, multiple pieces. So after it to concentrate it into small. We can vary, but standard we are using 80 microns as a laser diameter. Okay. So after that, once it is concentrated, it will be moved to the scanner unit. So in scanner unit, we are scanning the cross section, how much it has to move in depth, how much it has to move in width. Okay. After that, in that we are having mirror setup. So focused beam will be reflected into mirror. So after that, mirror will be reflecting, moving as per the cross section. So like that laser will travel by the help of scanner. So we can call this as a brain of the machine. Okay? So wherever laser has to move, it will be decided by this unit. Okay. So it is clear. Okay. So continuously here we are flowing laser So at this point more heat will be generated. Okay, if it is getting more heated, then function of that part will be decreased. To avoid that, what we are doing, we are giving two types of cooling system over here. For polymeter, we are giving water cooling system, and for scanner unit, we are giving air cooling system. Okay, for air cooling system, we have air compressor over there. For water cooling system, we have a chiller. Okay, so this is about this side. Is there any question? चलो आप लोग कुछ देख रहे हैं या बात कर रहे हो? देख रहे हैं? नहीं बोलो तो हो गया है तो चलो ये एक्सप्लेन किया था सब. To turn on inert gas flow, so now we discussed about inert gas. To turn on that flow, we have one option which is called the PC flooding. If you click on that, inert gas flow will turn on. So here you can see that it is giving one instruction. Place the outlet duct. So what is outlet duct? I let you know. So this machine totally sensorized. So if feedback is not coming from any other sensor, process won't continue. You need to get feedback from all sensors. If feedback is not there, process won't continue. Okay. So to turn on PC flood, turn on inert gas flow, we have a button. You can click on this one. Okay. After that, to turn on preheater. So again we are preheating the bed. For that we have a heater enable option. If you click on this, heater will be turned on. So here again you can see that it is showing the some lock the door. Actually door is not locked properly. If here also again sensor is there, feedback is not coming from the sensor, again process won't be continued. Okay, mainly for safety purpose. Okay, after that, if heater is on, so what is the temperature of the heater? Okay, it will be shown here, heater value, and as per your requirement, you can change the heater value also. Okay, here you can see the heater temperature. So in case of aluminium, we are keeping 200 degrees, so that can be given. So depending upon your requirement, you can modify it. So maximum will be 200. So in case of SS, we are keeping 80 degrees. So depending upon material, you need to change it. Okay, so in our case, we are keeping 200 degrees as a bed temperature.
Shouldn't it be more for SS?
No, actually, why we are keeping more? Because it absorbs, it is a good conductor, aluminum. It absorbs air. So after that, it releases air. But in case of SS, it will absorb also less, to release also less. That we are keeping 80 degrees. Okay. So after that, here you can see. So main thing we said oxygen. So we need to avoid oxygen. So what is the okay?
Why you are going out?
So after that, I told you about oxygen. So as you know, in normal atmosphere, around 21% of oxygen is there. So inside the chamber, currently we are having 20% of oxygen. So for better processing, we need to bring that oxygen less than 0.5%. Okay, currently it is 20. So while processing, before starting the process, it should come less than 0.5%. Then only we can start the process. Okay, otherwise what happens? Part will oxidize, it get oxidized. While operating condition, it may get corrupted. So about that, we need to wait up to 0.5, less than 0.5%. Okay. So after that, here you can see the dosage efficiency. So what is dosage efficiency? Mainly, so whatever part we are printing. So for example, we will take it as a 100 ml. For paper print, so I will show you, right? So while processing, whole printing chamber will be covered by powder, either unused powder or melted powder, but it is surrounded by powder only. So for paper print, we need to store 1.5 times more height of powder than the part. If it is 100, we need to store 1.5 times more powder in the display. So minimum 150. Okay, 150. Okay. So with available powder, whether it is possible or not, to check that we have one option here. So here you can see that layer thickness.
it is defined by the software. So now when doing slicing, we gave 0.04 mm.